We all know about pi, but let's discover e. Let's start off with 1 to the n. This is pretty boring. No matter how big n gets, this answer is always 1. Now let's look at what happens if I make 1 slightly bigger, so 1.01, but now to the power of n. If n is 5, we get 1.051. Pretty small still. To the power of 50, we get 1.6446. To 500, we get 144.77. So that's a lot bigger. And to 5,000, we get 4.044 times 10 to the 21. So this number is 22 digits large. So what we can say, as n tends towards infinity, my number is going to tend towards infinity as well. So let's look at this equation. Instead of just having a power of n, I'm now going to change my additive part by what that value of n is. So as this gets really big, this additive bit is going to get really, really small. So we're going to start fighting each other. So when n is 5, 1 plus 1 over 5 for 5 is 2.4882. So it's getting bigger. When n is 10, we get 2.5937. So again, bigger, but not as much. When n is 100, 2.7048. With 1,000, we get 2.7169. So to 100,000, my number is 2.7182 and so on. To 1,000,000, my number is still 2.7182. So what's happening? As my value of n starts to get really, really big, all the way up to the millions and billions towards infinity, my output doesn't change. My output stays the same. It stays as 2.71828 and so on and so forth. And this is such a special number when it comes to A-level maths. This is so special, it has its own letter, and it is E.